Okay, so for people catching up on the video, these are parent functions, and we said the greatest integer function is f of x is equal to, and we used this notation because that's what the book uses. And again, we have these open circles with closed circles. Very bad graph on this small spot here, but that's where we picked up. So we go to power functions now. This is kind of interesting. We're going to do f of x is x squared. We're going to do f of x is x to the third. F of x is x to the fourth, and we'll do f of x is x to the fifth. And we're going to investigate those a little bit. What does x squared look like? It's a parabola, and its vertex is at 0, 0. Heads up like so. Anybody know what x to the third looks like? Yeah, kind of like an S. I don't know if that's... I don't know. Just to give you guys an idea, x squared, parabolas, we're gonna transform those. We wanna make them look different, and so we're actually gonna graph ones that look like that. And for cubic, we're gonna graph cubic ones that look like that. Okay, so we're gonna change things around and we're gonna make them look different. Okay. Now, if it's to the fourth power, do you think it's going to look more like the cubic or more like the squared? If you cube something, can you get a negative result? Yeah. If you square something, can you get a negative result? No. If you take something to the fourth power, can you get a negative result? No. So it stays positive. And what it does is it kind of flattens out around 0 a little bit. And then 5 can be negative. So I exaggerated those, but we're going to investigate it on our graphing calculator here in a little bit. But and we're going to make those look differently. So a fourth powered function or a quartic function, you might have ones that look like that as well. And then fifth power, you might have something that looks like that. So there's all sorts of behavior that can happen within polynomials that we'll look at. Take out your graphing calculator. Tangent line is going to be in the form of y equals mx plus b. You need to find your slope and then use your point on your line. You're graphing the derivative right now. Okay, so what I'm going to do is I'm going to type in x squared, and I'm going to make it bold. So let's go over to the side here. We'll make it bold. Now I'm going to go down to y sub 2. And what I'm going to do is I'm going to type in a function that's to a large degree. So you guys kind of saw what happened with x to the fourth. We're going to make that even bigger, and we're going to type in x to the 10th. X to the 10th. And I'm going to graph those in a 5 by 5 window because that's just going to help see it better. So I have negative 5 to 5 and negative 5 to 5. Watch what the graphs look like. Watch how they are different. There's x squared. You see that? I'm going to take off the x squared and I'll graph it again. Look at how it, look at how steep and rigid it is. You see that? That's because if you take a decimal to a fourth power, it's going to make it really small. But as soon as you get past the value of 1, if you take something to the fourth power, it's going to make it very big right away. So that's what we have. So if we switch that and we go x to the third, and then we go x to the 11th, so if we make odd powers, again, you can get negative numbers with odd powers. And look at the graphs. Whoop, what happened there? Let's check that again. I didn't have the exponent. 3x, very interesting. Here we go. Thank you, Jensen. You're so smart. And you take great senior pictures. Okay, so you can see how it kind of flattened out there. And if I get rid of that cubic one, and I go graph, you can see now that I do have a much more rigid shape for the same reason. Does that make sense? So as you increase that power, that's what happens to the nature of those. Which, by the way, yes, I'd love to have more senior pictures. I have 4. And right now, those are my... I've got Tara, Jensen, I've got Devin, and I've got Trenton. Tara Jensen? All right. Okay. Root functions. These are interesting. Well, all math is interesting, but Riz, you're really going to love these. Okay, can I not call her Riz? What? No. You just want to make fun of me. It's like, Sarah Savicool, you have a habit of bullying. You know that? Or whatever. Let's see. What do I want to do now? Okay, let's look at those. I think that those are interesting. That's what the square root of x looks like, right? Now, I want you to think about something. You got to think about this pretty hard, okay? What kind of numbers can you take the square root of? Only positive, right? So our domain is x is greater than or equal to 0. But what about cube roots? You can take negatives as well. So you're also going to see how this graph only goes to the right? Well, this graph is also going to go to the left, and it actually looks like this. It's kind of cool, huh? I'm going to switch this one. I did a bad one there. I'll try different. We're going to cube root of x squared for that one. Now I want you to think of something here. What kind of numbers can you take the cube root of? Can you take cube root of positives? Yep. Negatives? Yep. But when you square something, you only get positives. So you said I could take square roots of negatives, but, or I could take, I'm sorry, cube roots of negatives, but the negatives all turn to positives. Let's see what it looks like. Let's graph. The cube root of x squared, how do you write that as a rational exponent? X to what power? Two-thirds. Very good. 2 over 3. And I graph that. It's kind of neat. Riz, don't look so excited. Kind of like a bird, isn't it? You know, like an artist that's not very good at drawing stuff. You just kind of sketch. Or like a 5-year-old bird. Birds don't live to be 5. Okay. Well. Oh, Mallory. Good for you, Mallory. Mallory, I look forward to class every day because of you. All right. So we've got that one. But let's switch it just a little bit, okay? So what if we do this? What if we do the 4th root of x to the 3rd? Think about it. Think about it. If you cube something, can you cube positive numbers? Can you cube negative numbers? Can you take the 4th root of positives? Can you take the 4th root of negatives? No. So you can't take the 4th root of any negatives over here. So this one actually is kind of boring. It heads off like that. Kind of like the very first one. So, you know, you can play around with rational functions and see exactly what they look like. I think that those are interesting. Okay, f of x is 1 over x. F of x is 1 over x squared. Boys, girls, boys. We have f of x is 1 over x, or f of x is 1 over x squared. Those are what we call reciprocal functions. Those have another interesting shape. But again, you got to be able to look at it and understand algebraically what the graph is going to look like. Specifically, what number is not in the domain of this function? 0. Why, Casey? Why? Why is it undefined at 0? Because you can't divide by 0. So therefore, in this problem, we have a vertical asymptote. I'm going to write this down. Now, when I first came to Albert Lee High School, and I was helping pre-calculus students with mathematics, I used the term asymptote, and they looked at me like I was stupid. They looked at me and they were like, it's not asymptote, it's asymptote. Well, I want you to know that the dictionary allows you to pronounce it asymptote or asymptote, either way. I prefer to pronounce asymptote. I don't like asymptote as much. It makes me feel like I'm saying a naughty word. But yeah. Now, there is a horizontal asymptote as well. I want you to think about this very carefully. There's exactly one number in the output, in the range, that this cannot achieve. And it is 0. This function can never be equal to 0. If you set 1 over x equal to 0, you won't find a solution to it. On 0. And so your graph actually looks like this. Those asymptotes are what the graph approaches but never touches. It has that shape. Now, the second graph is very similar to that one, but is slightly different. Do you know in what ways it will be similar? Same asymptotes. Think about it, people. I have x squared in the denominator. What happens if you square something? Okay, and that will make it what kind of a number? Positive. So we don't have any negative numbers here. You said negative, Jensen. Don't make stuff up. Whatever. Just make up lies. So that's what you have. Okay? So those are reciprocal functions. All of these functions you should commit to memory. And when I say that, don't think that I'm going to somehow memorize them for you. Buy yourself a bunk bed, post these on your ceiling, look at them before you go to bed at night, memorize them. That's what you got to do. Okay? All right. Here we go. Flip it over. One, 2, 3, 4, 5, 6, 7, 8. Your time's up, Skywalker. All right, f of x, vertical shifts. We need to now shift these things, vertical shifts. F of x maps to negative f of x. What does that do? Whoa. I'm way off here. Okay. The one that is example 1, we're on page 2. F of x maps to f of x plus k. Okay? So what happens here is this is a shift up or down k units. Is the K on the outside or the inside? It's on the outside. So therefore, it's vertical. If it's a horizontal shift, f of x will map to f of x minus h. And it will shift left or right h units. Is the h on the inside or outside? Inside. So therefore, it is horizontal. If it's on the inside, it's horizontal. If it's on the outside, it's a vertical piece. This is what we have. I'm going to put one more thing by the description. This is super important. In order to figure out what the shift is, solve x minus h equals 0. Don't just look at it. Solve it. So let's try these. Identify the parent function of the following, graph the new function, and describe the transformation. A for the date. What's the parent function for this one right here? The parabola. So the parent function is f of x is equal to x squared. Parent function looks like that. So it used to be you looked at x squared minus 3. You're like, I wonder what that looks like. Well, now you know exactly what it looks like. How is it different from that? Down 3 units. Very good, Bailey Barber. Bailey says down 3 units, so I go down 3. And I draw it. There it is. No, I draw the parent and the other one so that you see the difference. I don't care what you draw. You're in charge of your own learning. What is the second one, parent function? F of x equals what? Square root of x. Very good. Which looks like this. Again, you should have all those shapes memorized. Is this a horizontal shift or a vertical shift? Horizontal, because it happens on the inside. How many units is it going to shift? 4 units. Which direction? X minus 4 equals 0. Solve. What is x? 4. 4 units to the right. Next one. What's the parent function? X cubed. Looks like this. 2 transformations here. What are they? Very good. Hannah DeVries is a genius. Down 3, left 2. I solve x plus... Hey, what happened to my pen? Go Gadget Smartboard. See, now it blinks red. I'll go back to green and blink a bunch of times. Nope, it just went. All right, there we go. So I've got x plus 3 equals 0. I solve for that, and I get x is negative 3. So it's negative 3 units horizontally. Then you see this minus 2 on the outside, so it's 2 units down. So I have 2 units down, 3 units to the left, and that's my shape. If I wanted to know if that was correct, what could I do? Yeah, punch both into your calculator and see if they look the same. Next one, what's the parent function? Absolute value of x, what does that look like? A v. A very wide v. If you drew that in kindergarten, you might get sent back to preschool. Okay, so I have 2 translations here. What, or 2 transformations, what happens? Down 3, right 4. Right 4, down 3. Right 4, down 3. This is a review from last year, yes? Okay, and instead of spending 2 weeks on it, we're spending 2 days. Any questions? Okay, we got through this last or second period, so we're going to try to do this really quick too. Okay, vertical reflection takes f of x and maps it to negative f of x. That's a reflection over x-axis. Is the negative on the inside or the outside? Outside. So therefore it's a vertical transformation. It's on the outside, it's vertical, inside horizontal. If you take f of x and map it to f of negative x, well, that is a reflection over the y-axis. And as you can see, the negative this time is on the inside. That's what makes it horizontal. So if you got a negative, just identify if it's on the inside or outside. That'll tell you type of switch. Now, this is horizontal reflections are what get confusing for people. I don't want you to think about it too much. There's only a few cases where it actually switches horizontally. I just don't want to spend a lot of time on that piece. So we'll talk about it. We'll talk about it. Okay. Negative square root of x. Parent function. What is it? Square root of x, which looks like that. What happens if I put the negative on the outside? What? Reflects it over the x-axis. So it's going to go like that. That's pretty cool. This is the most important one for you guys to think about a little bit here. This is where people get confused. 3 minus x quantity squared. First of all, what's the parent function? X squared, which looks like this. There's two ways to do this problem. I'm going to tell you the way I think is least complicated for you, okay? First of all, true or false, there is a horizontal shift involved. One of these type of things. True or false, there's a horizontal shift involved. True. I solve 3 minus x equals 0. So x is what? Not negative 3. Positive 3. So there's a shift 3 units. Okay? So I could shift it over 3 units. Now, think about this. If you were to square this out, would the x be positive or negative? The lead term, x squared, would it be positive or negative if you squared it out? Positive, so it's going to go up. Why are you looking at me? I look good every day. All right. Tomorrow I'm going to try to ignore Sarah Savicool the entire day. See what happens. All right. You guys, I'm going to show you this, and I don't want you to get confused, but I just want to show you because when you see this negative x, that looks like a horizontal reflection piece, doesn't it? Watch. Would you agree I can rewrite this like this? Negative parentheses x minus 3 squared. Is this the same as that? These are the same, aren't they? So you can see you have this negative, which means you reflect it around the axis. And then you have an x minus 3, which means you move it 3 to the right. But if you take a parabola and flip it around the y-axis, does it change shape? No. So you can see what's happening here, okay? I like to think of it like I first told you and not the other way. Okay, we'll have to finish up the 2 other problems tomorrow. And we got to finish these notes, and then we'll let you do your assignment.